Hello everyone. In this video, let's work out the problems based on substitution method. Few more problems we are going to work out so that you would be getting an idea about how to solve the different types of problems under substitution. So here we have with the trigonometric functions mostly in this problems whatever we have selected. Let's start doing it. First problem we have integral cos root x by root x dx. Let's consider it as I is equal to. Now, which one do I consider as my t, the substitution? Now, whenever I find something is as composition of cos of another function is there, obviously a square root is there here. So obviously I would be considering the root x thing as my substitution. So let me start with let root x be equal to t. Now, when I differentiate, I would be getting it as 1 by 2 root x dx is equal to dt. It means I'm differentiating both the sides with respect to x. And after that, we have 1 dx by root x we do have, but 2 we don't have. That means dx by root x is going to be equal to 2 dt. Now let's go ahead and do the certain changes because in our I, now I would be getting changed from variable x to variable t. So I would be having cos t 2 times. So let me bring that 2 out and then dt we have since 2 is a constant. Now when I integrate cos t, I would be getting sin t plus c. So now what is my t? Let me just replace that back from where I started. So sin t becomes root x and then plus c. That's it. It got over. A very simple approach this was. Now let's move on with the second question. We have I is equal to integral root sine 2x. The root is there only for sine 2x. Then I have cos 2x dx. Now how will I go ahead and go for substitution? Now something which is there inside the root is gonna act as my t, substitution. I told composition of a function, something which is inside a function, something which is preserved a type. These things works as a substitution mostly, 99% of my problems. So let's start with that. Now here I have let sine 2x be equal to t. That means I'm going to differentiate this both the sides with respect to x. Now, when I differentiate sine, I get cos 2x as it is. Now, after this, I need to differentiate this 2x separately. When I differentiate 2x, x becomes 1, and then 2 into 1, I would be getting 2 times cos 2x. And then is equal to dt by dx. This is how I would be getting. What exactly is happening is a chain rule. Whenever we have a chain rule, what we need to do, differentiate the outside function first as a whole, considering as a 1, and then differentiate the inside function. This is how we do it. So now here, what exactly, mostly I've told my students also regarding this. See, we have a mother, a pregnant woman. Okay. So when the pregnant woman has her food, she gets all the energy first. And then later, that is getting the energy is like the baby is getting that energy, the baby which is there in the womb, that child gets the energy. So first what you need to differentiate the mother function followed by the child function. That's how the chain rule works. Mother, when you're considering, consider it as a whole. Don't think about 2x or something else and all. What is the differentiation of a mother function as a whole? Let's do that. That's the reason when I differentiated sine 2x, I gave it as cos 2x. Then I'm going with the child function 2x. 2x when I differentiate, what I get? 2. Both are getting multiplied. That's it. And we get our result because it's just one single function only. That's how it is. Okay. So hope you understood. So based on that only we have done with our differentiation. Now let's go ahead and do the changes. So here I have root of sine 2x is there. That is gonna get changed as root t. And then cos 2x dx, I would be writing it as dt by 2. So dt and 1 by 2 would be coming out because it's a constant. So now when I integrate t to the power half, I would be getting t to the power half is nothing but root t. I would be getting t to the power 3 by 2 divided by 3 by 2 because 1 by 2 plus 1 is 3 by 2 and then plus c. Now what happens? This 2 which is there, it is denominator, it comes to the numerator and 2 would be getting cancelled. 1 by 3 t to the power 3 by 2 plus c I would be getting. So now what is my t actually? T is nothing but sine 2x the whole to the power 3 by 2 plus c. Okay, that's it. Done. We are done with our problem. So remember the concept behind the chain rule because if you know chain rule, most of the problems under substitution we would be able to do without. Here, whatever the problems I have selected, it comes mostly by chain rule or some or the other different approaches only I have selected. Now let's start doing with the next one. Here we have like integral cos x divided by root of 1 plus sin x dx. So let's start doing this. Now, what I would be considering, obviously the one which is inside the square root, which is preserved, I would be considering. But when I'm considering, I just want to do a cross check within in my mind itself that when I take 1 plus sin x as t, when I differentiate 1, it becomes 0. Sin x, when I differentiate, I get cos x then is equal to dt by dx and whether that is there as the other part of my question. Yes, it works. Cool. Then I can go with that substitution. Now let 1 plus sin x be equal to t. Then in that case, when I differentiate both the sides with respect to x, what I would be getting? Cos x is equal to dt by dx. Great. Now cos x dx is going to be equal to dt. Now let's go and change our I, which is there in x variable to t. So cos x dx becomes dt divided by root t. So when I integrate this one, I would be having, I'm actually integrating t to the power minus half. So minus half plus 1 is going to be plus half. So t to the power half divided by divided by half plus c. So I would be getting 2 times root t plus c. So what exactly is t? It is root of 1 plus sin x plus c. That's it. Done. Okay, let's move on with the next question. Huh. This particular problem is a quite a different approach. See here. In this particular problem, we can come with the two approaches, but I'm going to use the approach, a substitution approach. The second one, which I'm going to tell, because the first one I will tell you what exactly happens. Let's go as per whatever we did till now. So now, which one would we consider as T? So till now, whatever I've been told, based on that assumption, if you go for substitution, the one which is inside protected, the composition of a function or something like that. In that case, log of sin x, then we would be going with let sin x is equal to t. Okay. I never preferred this one. Why I will tell you now. Let me just sort out what exactly the problem occurs in this. Let me just tell you that. When I go ahead with the differentiation of this both the side with respect to x, I get cos x dx is equal to dt. Okay, do I have cos x in my question? Yes, it is there. Right now it is in a hidden format. How? Because cot x can be written as cos x divided by sin x and then log of sin x. This is how the problem is for us. Dx. Now you tell me, do you have cos x dx? Yes. and that becomes dt, and log of sin x is t divided by sin x, this is t, and then we have dt. Now this is how my I is getting changed to. But again here, I need to go for another substitution. Alright, because I have log t by t, how I would be going ahead. So now here I would be going with another substitution, considering u is equal to log t. Then when I differentiate both the sides with respect to t, I would be getting du is equal to du by dt is equal to 1 by t. And then again, we would be doing the problem. So this is like 2 times substitution I'm working out. Actually, it's a waste of time. That's the reason I never prefer going with this one. I will tell you an easier way where we can do it at just like one substitution. That would hold. So this one I'm not considering because twice I'm going for substitution. Twice substitution procedure we are working. Okay, now here, let me do the change. Let it be cot x, and here I have log sin x dx. My substitution would be simple. Let t is equal to log sin x. So in that case, when I differentiate both these sides with respect to x, I would be getting dt by dx. In the previous problem, the second problem, we spoke about chain rule. Here also I would be using the chain rule to differentiate. When I differentiate log sin x, what I would be getting? I would be getting 1 by sin x, right? And now, when I differentiate sin x, the child function, the mother function was log. Now I'm differentiating sine. So when I differentiate sine, what I would be getting? Cos. So cos x. And that's it. Got over. Now what is this equal to? It is nothing but cos x by sin x is nothing but cot x. Dx is gonna be equal to my dt. Problem solved. Now it's quite simple. Now how my I is getting changed to you just have a look. It becomes t dt, and you know integration for t, which is t squared by 2 plus c. What is t actually? It is log sin x, the whole square, and 1 by 2 we have plus c. That's it. Got over. So I would say that procedure what you did earlier is right. I'm not saying it's wrong, but it's a waste of time. It's a little bit logically. So if I take sin x, one part of my problem, everything is getting converted to t. I don't have any trouble with that, but again, I need to go for substitution. Whether that can be stopped, that's how the approach has to be. Okay, let's move on with the next one. Now we have, okay, sin x is equal to 1 plus cos x. So let's have a check with this particular problem. Which one shall we go for substitution? Okay, we would be considering, okay, well, if I take a sin x, when I differentiate, I get cos x. It is there, but it's there in the denominator. And I have one more term also, which is there in the denominator. So my preference would be taking that denominator as a t. So 1 plus cos x is going to be equal to t. That's what my substitution would be. Then in that case, I would be getting, when I differentiate both the sides with respect to x, 1 becomes 0, and cos x when I differentiate, I would be getting minus sin x is equal to dt by dx. So that means minus sin x dx is going to be equal to dt. Okay. So now here negative is not there, so it's going to be minus dt there. So let's do the change. Here, the substitution when I'm doing, I would be getting minus dt divided by t, which is equal to minus ln of mod t plus c. What is your t actually? Replace it back. It is going to be minus 1 plus cos x plus c. That's it. Okay, now let's go with the next problem. Now it's very similar, but we have whole square. So you would have understood what we would be doing Which one to consider for substitution? That remains the same. So obviously my denominator, which is 1 plus cos x, this is going to be the substitution. I'm not taking whole square. Don't do that. The inside part of the function alone you take. Okay. Then in that case, when we get differentiated both the sides, I would be getting minus sine x is equal to dt by dx. So I would be having sine x dx is equal to minus dt. Now let me just replace everything from x to t. I would be getting minus dt divided by t square, which is nothing but minus t to the power minus 2 dt. Okay. Now, when we just go ahead and integrate it, I would be getting minus t to the power minus 2 plus 1 divided by minus 2 plus 1. So I would be getting, see here, minus, because this t to the power minus 2 plus 1 is gonna be t to the power minus 1, which is 1 by done. And here I would be having 1. And I would be having one more negative that becomes positive. So plus c. So what is my t actually? T is 1 plus cos x plus c. That's it. So what exactly I did, I just wanted to show you. I would be having minus 2 plus 1, minus 2 plus 1. This is how I would be getting after integration. So t to the power minus 1 divided by minus 1. And then here already a minus is there, okay, plus c. So that minus and this minus becomes positive, and I would be getting 1 by t to the power 1. This is how I have got it. Now let's move back, move to the next problem, which is 1 divided by 1 plus cot x. They are asking me to integrate. So if you observe this problem, that is seventh problem and the eighth problem, both are of similar type. One I have cot, the other one I have tan. So in this case, we have not seen for cot and tan what to do. So whenever you have this cot and tan coming along with 1 plus or 1 minus, go with your sine and cos. That means change the cot in form of sine and cos. So how you will be changing it? Cot x is nothing but cos x divided by sine x. So let's do that now. Consider this as I is equal to. Then after that, what you would be doing here is 1 divided by 1 plus cot x is there. How you would be writing? You would be writing it as cos x divided by sin x dx. Okay. Now we take the LCM. So the LCM part is going to be 1 divided by sin x plus cos x divided by sin x dx. So now the sin x which is there in the denominator's denominator comes to the numerator. So I would be having sin x divided by sin x plus cos x dx. Okay. So now just observe, see here how I have got it. And now what we need to do here is I'm gonna write it, okay, in such a way that the denominator and numerator it should appear in the same way. Okay, so what we are going to do, I'm going to multiply and divide by 2. See, we have not seen any type of formula for integration of tan x. So next video would be based on that. I'm not introduced. So without introducing that, I'm not going to introduce anything here. So what I would be doing here is, we may not be able to do that as well. So this one would work. So let's have a check. Okay, I just wanted to tell you about that. So only I just told. So when I multiply and divide by 2, so I would be having 1 by 2, 2 sin x divided by sin x plus cos x dx. What exactly actually we are going to do here is, I'm going to make my numerator very similar to my denominator. Okay. So now here half I have sin x. Okay. Then plus cos x. So I'm introducing cos x also. And then plus again a sin x. When I'm introducing cos x, I need to balance it. So I'm introducing minus cos x here. So both plus cos x and minus cos x gets cancelled means I would be having 2 sin x. Okay. Divided by sin x plus cos x. Why did we do this? See here, I have only one term in my numerator, whereas in my denominator I have two terms. When we have in that format, cancellation is not possible. Okay, the cancellation is possible only when we have one term in my denominator and two terms in my numerator. In that case, we can split in this way and the cancellation is possible. When you get a proper heart, the cancellation is possible. When you get an inverted one like this, that means one person here and two persons in the denominator, then the cancellation is not possible. Here only cancellation would be possible. So that's the reason we are taking a help to replace our numerator in the very similar manner as our denominator so that the split up can happen. Now, if you have a check very carefully, you get a split up in this pattern. So you're able to split in this pattern. So I can split and write it as half of integral sin x plus cos x divided by sin x plus cos x dx plus integral sin x minus cos x divided by sin x plus cos x dx. Now what happens? This one gets cancelled. So I would be having half integral dx. This one, what I have is, okay, here I would be going for substitution with this part of my problem. It's very simple. The denominator you consider always for substitution. You get your numerator. Okay, so let's have a check here. After this, I would be going with the substitution. Let me show it to you. Let me add few space. I think this problem is going a little bit big when compared to the all other problems, whatever we did earlier. So now here, let me integrate this part, half of x, plus what I have here. Okay, I'm considering it as half I have left out, half I1. Okay, I'm considering it as I1. Now I1 is equal to integral I have as sin x minus cos x divided by sin x plus cos x dx. Okay. Now let's go with the integration. So substitution method. I would be considering sin x plus cos x is equal to t. So when I'm going ahead and differentiating sin x, I get cos x minus sin x and then dx is equal to dt. This is what I get. Okay. Now if you just observe, I have sin x minus cos x here and here I have cos x minus sin x. So what that means, I need to take negative out. In that case, I would be getting sin x minus cos x. I'm taking negative common. Dx is equal to dt. Now the problem would be getting replaced. It got over. Okay. The problem would be getting replaced as I1 is equal to minus dt by t, which is minus ln of mod t plus c. So what I would be having here is, okay, see here, minus ln of t is gonna be sin x plus cos x plus c. Now this one we would be replacing it in our I. Now I is equal to half x plus half of minus is there. So what I will do, I will change it to a negative sign. So minus of, I would be having ln of sin x plus cos x plus c. That's it. Though the problem is lengthy, it's quite simple. We need to know few basic things like when to cancel, when not to cancel, all those stuff. If we know, it is quite easy. Okay, now let's move on with this next problem. So let's have a check with that one. It's also similar type of this one, what we did now. So we would be doing in the same way. So let's have a check there. Even there, one part would be substitution and one part would be without substitution. So now we have, considering this as I is equal to integral 1 by 1 minus tan x by tan x dx. So how we would be doing here is, let 1 minus tan x is there, right? I would be considering it as 1 minus sin x by cos x, okay, dx. So here we would be having cos x divided by cos x minus sin x dx. We have two terms in our denominator and one term in our numerator, so cancellation is not possible. So what we would be doing, I need to make it similar to my denominator. So first I will multiply and divide by 2. In that case, I would be having 1 by 2, 2 times cos x divided by cos x minus sin x. So here I would be having 1 by 2 cos x plus sin x and then plus cos x minus sin x divided by cos x minus sin x. Now if you observe, I have 1 by 2 and 2 I have dx. So I would be having like cos x plus sin x divided by cos x minus sin x and then dx plus cos x minus sin x divided by cos x minus sin x dx. So these two would be getting cancelled and then we have half of I would be having integral cos x plus sin x divided by cos x minus sin x dx, and I have plus dx means here it would be plus x, and obviously plus c, okay, is there. I would put that totally after integration. For x there is a c and then for this one also is a c. Two constant together we get another c. So if you want plus c, you can go ahead. Now here, I would be going with a substitution. Now I would consider something as I1. I1 is equal to integral cos x plus sin x divided by cos x minus sin x dx. So now what we would be doing is, I would be considering t is equal to cos x minus sin x is equal to t. So when I differentiate cos, I would be getting minus sin x. And then minus cos x, sine when I differentiate, is equal to dt by dx. And then minus, let me take common so that it helps me in the same way, because you can just observe the numerator and this particular one which we are getting, both would be same. Dx is equal to dt. Now let me just do the changes in our I1, converting the variables of x to t. I would be having minus dt divided by t. So minus would be coming out, and then ln of mod t plus c, which is equal to minus ln of, what is my t actually, is cos x minus sin x plus c. Okay. Now let's just go ahead and replace it back. I would be having the final answer as I is equal to minus half of ln of cos x minus sin x, and then I would be having plus x by 2 plus totally 1c. That's it. Problem got over. And if you want, yeah, I don't like negative first, so I will just replace it. Minus 1 by 2 ln of cos x minus sin x plus c. That's it. Though the problem was big, the concept was very quite simple. So, but this one is something very important type of problem, because that's where we do mistake. So people try to give those kind of problems where we do mistake. That's what they enjoy. So now let's move on with the next question which we have. So we have root tan x divided by sin x cos x. So what we need to do here in order to make it quite simple, like where I can use my integration formulas. So here, see, tan x is there somewhere in the numerator, okay? And it's a composition of a function, obviously, root is there and inside trigonometric function is there. And if I consider tan x to be equal to t, I would be getting secant square x dx is equal to dt. But do I have secant square? I have only secant, but I don't have secant square. So what I need to do now, before going for substitution, I need to make it in such a way that I get a secant square in my question, so that the problem would be getting resolved. The substitution, what I wanted to do, can succeed. So your substitution is tan x, no doubt in that. But when I differentiate, I get secant square x. But my part of the other part of my problem is having only secant x. It doesn't have 1 by cos is nothing but secant. That's what I'm saying. But I don't have secant square. So that means I need to bring secant square in the other part of the problem. Then I need to go for substitution, whatever I wanted to do, like a tan x. So now what we would be doing here is, I would be going ahead with a substitution now. Before that, a small change I would be doing in my question. Let's consider I is equal to. Now here, root tan x, let it be as it is. And then I have sin x. I won't disturb this as well. And then I have cos x. See, secant square is nothing but 1 by cos square. I have only cos. So what I need to multiply and divide by? I need to multiply and divide by cos x, so that the question is getting changed to root tan x divided by, okay, let me write this cos x also. I will do that in the next step. And then we have sin x, we have cos square x. Wow. And then dx. Great. Now I will do one more change here. This cos square, I'm going to write it as secant square x root tan x. And then the denominator where I have the sin x, the cos which is there in the numerator here, it comes to the denominator's denominator. What I always say that denominator's denominator becomes the numerator. So I'm going to bring it in this way, cos x dx. Now if you observe the entire problem, I'm changing it as secant square x into tan x divided by a tan x dx. Great, the problem is done. Now here what we would be doing here. Now you can go for substitution what you wanted to do. So now here, before doing a substitution, one more thing if you observe, this gets cancelled and I get a root here. Obviously, when we have root 2 divided by 2, when you cancel, you would be getting 2 because 2 is nothing but root 2 into root 2 by root 2. That's how it happens. So now here I have secant square x dx by root tan x. So now I would be going with a substitution. Which one? Obviously my tan. Tan x is equal to t. Then when I differentiate it, I would be getting secant square x dx is equal to dt. So my I would be getting changed as dt divided by root t. And root t, when I integrate, I would be getting 2 root t plus c. I'm doing this directly. So 2 times, what is t actually? It is tan x plus c. That's it. Got over. A quite interesting one. Okay, now let's move on with the next one. We have 1 plus log x the whole square by x plus c. So I think there is nothing here. Easily you can have a check which one is going to be your substitution which you're going to use. Obviously, one which is inside preserved within the bracket is composition of function. Let's have a cross check once. I would take t as 1 plus log x. Then when I differentiate, I get 1 by x dx is equal to dt. That's another part of my question. My problem is resolved. So now let's proceed. Let 1 plus log x be equal to t. Then in that case, I get 1 by x dx is equal to dt. Done. Now we are integrating both the sides. Integrating what we would be getting after integrating. Let me just substitute. I'm sorry, I used the wrong term. I don't know how. Not a wrong term. What we would be doing here is I is equal to, I would be writing it as, let me do the change here. It becomes t square dt. So t square dt, when I integrate, I get t cubed by 3 plus c. What is my t actually? It is 1 plus log x, the whole cube by 3 plus c. That's it. Solved. Quite simple it was. Now we will go with one more. Let's see what we are going to do here. The same type of problem, a little bit they have complicated. So what has been done here is, see, they gave me x plus 1 extra here. We have 1 plus log x here by x, but we have x plus 1 into x plus log x the whole square by x. So something extra has been given for us. So how to do this problem? See, we would be considering one which is there inside, that is the whole square, x plus log x to be my t substitution. But when I differentiate that, I get 1 plus 1 by x dx is going to be equal to dt. But do we have that in my problem? Yes, it is very much available, but it is there in the hidden form. So that hidden form, I'm going to break it. Now, let's see what we are going to do. I'm going to consider this as I is equal to. Now, see what we are going to do. I'm just going to write my integrand and show it to you. I have x plus 1 by x into x plus log x the whole square. This is what I have. Okay. Now see this one. I told we can split when we have one person in the denominator and the two persons in the numerator. I told you very clearly the splitting can happen in this way. Okay, the same way I'm going to split and write it now. So if I do that, I would be getting x by x plus 1 by x and then x plus log x the whole square. So here, when I cancel, I would be getting 1 plus 1 by x. See the hidden form of our substitution, which is there. Log x the whole square. Now, let's proceed with our problem now. So this is what is there under integration dx. Now, let x plus log x be equal to t. Then we have 1 plus 1 by x dx is equal to dt. Done. Now we have that. I is getting replaced now. So t square dt. That's it. Then we would be having t cube by 3 plus c. So what is actually t? It is x plus log x the whole cube divided by 3 plus c. That's it. The problem got over. It's like we need to break few things that will be hidden form. We need to find out where exactly that is. Now this last question, it's a one of the quite interesting problem. Here also there are few things which is in a hidden form. Okay. See here, if you want, you can do the substitution using 2 times. I'm not going to do that. I consider that as a waste of time. The 2 times, what would be the substitution if you want? I can tell you that. Considering x to the power 4 as t first, and then tan inverse t as the second substitution, which I won't be doing now. I would be doing it in a simpler way. I would be considering this as I is equal to. Now, let tan inverse x power 4 be equal to t. This is what the substitution. And if you remember, I would have told you in the previous one, when we worked out the problems based on inverse function, the differentiation of tan inverse. When you differentiate d by dx of tan inverse x, it's going to be equal to 1 divided by 1 plus x squared. So that differentiation works here as well. But my x square, instead of x, I'm not having just x, I have x to the power 4. So it's going to be x to the power 4 whole square. I would be having, okay, see, it's a composition of two functions. I would be using a chain rule. First, I would be differentiating for tan inverse. So when I differentiate for tan inverse, I would be getting it as 1 divided by 1 plus x power 4 whole square. And then I would be differentiating the child function. Mother function was tan inverse, child function is x power 4. It's going to be 4x cube. Okay, then dt by dx when I'm differentiating both the sides with respect to x. So what I get here is 4x cube divided by 1 plus x power 8 dx is equal to dt. And then we don't have 4, so I would be having dt by 4. So now let's do the changes now. I is equal to, see here, the x cube divided by 1 plus x power 8, which we have here. Let me mark it with a different color and show it to you. This full thing is getting replaced. Okay. Now we have, that becomes dt, and we have 1 by 4 as a constant. I'm writing it out. And then sine of t, sine t. So what I would be having here is, we have sine t and then dt. Sine t and dt we have. So what is going to be the integration of sine? It is nothing but minus cos t plus c. Done. So what is your t actually? Minus 1 by 4 cos of, what's your t actually? It is tan inverse of x power 4 plus c. So we have done within few steps actually. If you go for double the substitution, then it would be a long process. This is your final answer. With this, I will wind up with this video. In the next video, we would be seeing few more problems, especially the formulas and all of tan, cot and all integration formulas we would be seeing. Thank you guys.